Here's a little example of how I present simplifying square roots. And of course, you gotta start off by knowing the primes, and so that would precede this. And so if you haven't done that yet, you got to talk about the primes too, in addition to this, because when we do the vertical factor tree, we always start off by with the smallest prime factor, which is 2, not 1, which everybody thinks 1's prime, but it's not. So I would start off with the primes first, 2, 3, 5, 7, all right, 11, 13, and generate, some primes, and know that there's an infinite number of primes. And prime numbers, tell the kids that they start at 2 because prime numbers are defined as any number greater than 1 whose factors are only 1 in itself, etc. And then, of course, you got to develop the perfect squares. Okay, we're talking about 1, 4, 9, 16, etc. And I always teach my kids to go up to the 20th perfect square, which is 400. And they generate this list on their own. And then we do verbal practice drills in the beginning of class, and we do this out loud verbally without looking at our notes. So this right here, this has to be mastered. Okay, so this is a mastery right here. They have to know these verbally and out loud, and we do this as a group. The first 10 are easy, but it's obviously beyond 12 where you have to get them to really understand. I'm talking about this right here, okay, from 13 squared on to 20 squared. And then you state the first basic rule in algebra dealing with roots is that the square root of a product is a product of the roots and or the factors. And they have to get used to a product and factors and speak the correct mathematical lingo. And the reason why is because we want to talk about factor pairs and factors of a number, because what we're going to do is we're going to find the biggest square factor inside each number, and we're going to square each factor and then simplify from there. So for example, I start off with factor pairs of the number. So if we're simplifying root 12, excuse me, what we want to do is write the factor pairs of 12, and we start small. All right, so the factor pairs of 12 obviously are 1 times 12, all right, 2 times 6, 3 times 4. And then, so we started understanding what factor pairs are all about, because what you want to do is pick the factor pair that involves the biggest square. And the biggest square in this, well, the only square in these three factor pairs is 4. So when we factor root 12 and rewrite it using our basic rule in algebra here, we rewrite it as root 4 times root 3, which just gives us an end result of 2 root 3. Or what we say is 2 rad 3, okay, or 2 times the square root of 3. All right, and so we know that the square root of 4 is 2. So I don't do any slang or anything like that. I actually teach just basic number sense and use the correct terminology. And I don't do the old factor table either. So, and we only do the vertical factor tree if the numbers get big. So when it's small, we just think factor pairs, like the square root of 18. Okay, well, 18 is 1 times 18, 2 times 9, and 3 times 6. And the students have to learn how to choose the factor pair that involves the square, which is obviously 9. So we don't use 3 and 6 like some people do. What we want to do is square root the 9 times the square root of 2, because a root times a root is a root, and we get 3 rad 2, or 3 root 2. All right, and so I develop it with small numbers first to get the idea, and then when we get to 3-digit numbers, that's when we use the factor table. And so, like the square root of 90, well, this doesn't really require the factor table. You could use it, but most people know that 90 is 9 times 10, so you get root 9 times root 10, or 3 root 10. And you have them step it out. And this is all done by using the whiteboard, so I'll be working with them. So I illustrated a couple, so I model this right here with me, right here. And then here, this is on these small student whiteboards here. And we go through a lot of basic examples with the whiteboards using small 2-digit numbers before we even graduate and think about examples 6, 7, and 8. So we do 3, 4, and 5 on the whiteboards, and they first work it out on the boards and then get it approved by me, and then they record their work. And yes, I have all my students record their work so they take it home because I think it's important and because they can't remember everything I say. So they've got to have a resource, and it's called their notes, okay? And then when we get to number 6 on, that's when I start using the vertical factor tree. So here we go. So I start off with 120 and I draw a vertical line, and then I put the word factor up here. And we want to start off with the smallest prime factor. So I'm going to write the word prime factor here. These are prime factors. And the smallest prime factor in existence is 2. All right, look back at the very top. This is the smallest prime factor up here. And then here we go. And I go take 120 divided by 2 is 60. And anytime I see an even number, we always divide it by 2. And if it's not even, then we switch. And then we use either 3, 5, 7, or any of these other prime factors. And so 60 divided by 2 is 30. Divided by 2 is 15. Now that's odd, so you can't divide it by 2. So you pick the next biggest prime factor, which is 3. And 15 divided by 3 is 5. 5 is prime, so you divide it by itself. And when you get 1, you stop. And the whole goal of this is to find the biggest prime factor. So I'm going to write that down. And we write this down for my kids. So the goal is to find, all right, the biggest, all right, biggest, excuse me, not the biggest prime factor. I didn't say that correctly. The biggest square, or the biggest perfect square, okay? Sorry, that was my bad. Biggest perfect square. And we write this stuff down. All right, and so the biggest square, well, 2 is not a square, but 2 times 2 is. And then, so anytime you multiply identical numbers, you get a square. 2 times 2 is 4. 4 is your second square. It's right up here in the list. It's the second perfect square. Now, the other prime factors, 2, 3, and 5, they multiply to 30, of course, because that's where they came from. All right, they don't produce a square, so what we just do is we multiply them together. 2 times 3 is 6, times 5 is 30. And then what we do is, well, guess what? We have our factors. 4 times 30 is 120. So then you take root 4 times root 30, and you simplify root 4 to get 2 rad 30. And you're done. And so what we do is we try to find the biggest square. And in this case, all right, it happens to be the 4. All right, that's the only square factor. Now, what students learn is that a square times a square is a bigger square. So let's see if I can get that involved. Okay, so let's work on root 75 first. So we write down 175, draw a vertical line. This one ends in a 5, so it's not divisible by 2 nor 3. And so we divide it by 5 because any number that ends in 5 is divisible by 5. All right, and so you got to be thinking, okay, so how many times is 5 divided into 175? And you go, well, 5 into 17 is 3, remainder 2. So let's try 35, maybe. All right, and so 5 times 30 is 150. 5 times 5 is 25. You get 150 and 25, 175. So that sounds good. Now that is divisible by 5 again, 7 times. 7's prime, divided by itself. And notice that we only have one square, and it's called 25. And 25 times 7 is 175. So you square root them both. Okay, I tell my students that when you split the root into two square roots, you square root both factors, and we write that down. And in fact, let me write that down. You square root both factors. Common mistake is some people only square root one of them. Well, guess what? You got to go back to our main rule in algebra. You got to square root both factors, not one but both, and so the end result is 5 root 7. And so you model this one. So this one you model, okay? And then this one is done by the students right here. So this one on number 7 here, this is on the whiteboards. So what I'm going over with you right now is how to teach it, not how to do it, because you know how to do it. All right, I'm not concerned with that. I'm just going over how I would do it and flow from me modeling to them doing. So I show them something, then I have them do it. Then I show something, then I have them do it. And then we develop it as long as it takes for them to get it. Number 8 is kind of special, all right? You'll see why here in a minute. So we take 180 and divide it by 2 to get 90. That's even, divided by 2, 45. And 90 divided by 2 is 45. And then that's odd and it's divisible by 5, so I would divide it by, or 3. You can divide it by 3 or 5. So it doesn't matter with the order here. You can divide it by 3 or 5. Most students would put 5 down because it ends in 5. It's easier for most kids, but if they put down a 3 here and divide it by 3, that's fine. And they get 9 here, and then 9 divides, is divisible by 3, 3 times. 3 divided by 3 is 1, and then you're done. Now the whole goal, as I said down below, is to find the perfect square. And what students don't know in the beginning is that a square times a square gives you an even bigger square. That can be proven. We actually prove stuff like that in MRWC. And so here 2 times 2 is 4, 3 times 3 is 9, okay? And then 4 times 9 is 36. And so your squares, your biggest square is 36, okay? Now the other remaining factor is 5, and 5 times 36 is 180. And most people don't know that initially, okay? Even calc students would have a hard time with that. But with the factor table, it's easy to find. And they get really good at it really fast. And so you just take root 36 times root 5, and you get 6 root 5. And kids that are good at this, and they get good at this, can whip this stuff out so fast after a while. After the second or third day, they can handle 3-digit numbers like within seconds. It's amazing. And in this right here, I have students that I had in 9th grade, and they come back to me in 12th grade, and they can still do this. That's how powerful it is. Okay, and I didn't come up with this little technique here. I learned it from someone else back in 1997 or 1998 or something like that, back in Anaheim High School. And I saw his students, and they were amazing. And ever since then, I started teaching it like this. And so it's that good, okay, because they never forget it. And you'll see how good it is. All right, and so there you go. That's how I would work it through. And then, of course, I would go to the whiteboards, and after number 8, this is one I model. Okay, I would do it. And then I would give them something like, I would make up something like example 9 would be the square root of, I don't know, 240. And I'd have them do it. And then the next one, the square root of 360 maybe. And then have them go for it. And just have them practice. And you'll be surprised in how fast they can simplify a root. All right, there you go, my man. All right, go for it and see what you think.